Question 4, a fairly quick one on parametric equations. We've got x equals tan theta, y equals 1 plus cos 2 theta, and we've got to eliminate theta and end up with a Cartesian equation, y equals 2 over 1 plus x squared. With these kind of questions where you have to eliminate theta, you've got to try and find a way of connecting these two so you can substitute one into the other. Now, it's not obvious in this question how you can get tan theta is try and substitute that into a cos 2 theta. So what I would suggest in that case is looking at the answer, look at where you need to end up, and that kind of gives you a clue that it's going to help if you do x squared and plus 1 to it. But you might also realize that if you do square x and you get tan squared, that is useful because now you can use the fact that tan squared theta plus 1, that would equal sec squared. So if we add 1 to both sides here, this is going to equal sec squared. And so this means that cos squared, if we just do the reciprocal of both sides here, 1 over sec squared, I'll just write down, so 1 over sec squared, that is cos squared theta. Okay, so we've now got this, which is useful because the equation for y has got a cos 2 theta in it, and you can replace cos 2 theta with 3 different identities. But since we've got x now in terms of cos squared down here, it's going to be helpful if we can get this in the form with a cos squared in it. So let's replace cos 2 theta with 2 cos squared theta minus 1. This is just coming from the double angle formula for cos 2 theta. You can see there the ones are going to cancel, and so we're just left with 2 cos squared theta, which means that we can replace that with this. So it's looking good now. It's looking like the answer we want. So y equals 2 times by 1 over 1 plus x squared, which is 2 over 1 plus x squared, which is the answer to that question.